I've done that twice this year. All right, factoring. We're going to talk about quadratic form and grouping. And we've kind of organized these a couple different ways. Okay, quadratic form applies to trinomials. That's 3 terms. Right. Grouping will apply to 4-term polynomials. Okay. So if you like to organize things in that manner, you can do that. Quadratic form is pretty straightforward. It's just like the factoring you know from quadratics. We just have different exponents. Right. So I could say factor Is this a quadratic? Yes. No, it's to the degree 4, right? Quadratic's degree 2. But we're going to factor it the same way.
Really?
Would yes.
You do it to 2?
Because the key here is how the exponents. 4, half of 4, and then obviously the constant, right? So the exponent is 4. That exponent is half of 4, and then the constant. Okay. So that's the key pattern, right? What?
For factoring, that's the criteria?
Yeah, if you want to use quadratic form, this is the criteria.
So it couldn't be like 2x to the third, it wouldn't work.
No. Right, this could not be a 3. We couldn't quadratic form this. Because if you look at, see, 2, half of 2, and a constant, right?
Yeah.
It's the same pattern.
So if it doesn't have a constant, it won't work either?
If there's no constant, what could I do?
Make a constant.
You got a greatest common factor here. So you would factor that out first. Then you would look at what's left. Okay, so let's factor this one. What do my first terms have to be to get x to the 4th? Squared now, right? So you have to pay attention to what you're putting there. And then, just like you factor it, just like a quadratic. So adds to get that, multiplies to get that.
So it has to 1.
Same as a quadratic.
Yeah.
1?
1.
1, yeah.
Oh. You just forget
Multiplies to get 1, adds to get 2, right?
You just forget about the exponent for that, for like that split second?
You can think of it that way. You two gonna join us here?
I've been over here.
Yeah, I have been, but you're not.
Wait.
Go bed.
Oh. Cool. Why did you put an x squared?
Because if I FOIL these, first times first is x to the 4th. Right. Your outers are x squared terms and your inners, right? And then the last is plus 1. So you can, again, check your answers that way if you need to. Okay. All right, so let's...
is that it?
That is factoring by quadratic form.
So that'd be...
It said factor, right? So do I need to go any further?
No.
No. Okay.
Wait.
But I could also say calculate the zeros of x to the 6 plus 5x cubed minus 6. Does that work?
Yeah,
it does. Okay, it's the same type of problem.
Would you still do x squared?
No. That's the, so if I'm going to factor that, what would my first term have to be? X cubed now, right? So you're basically, these will match the middle, right? And what is my factor?
Positive 5, negative 1.
No,
No, positive 6, negative 1, sorry.
Thank you for adding correctly.
You're welcome.
All right. Now, since I did ask for the zeros, we have to keep going, right?
Oh, dear.
It's 2.
Oh dear.
No, it's not.
How do I solve the zeros?
It's a
Set it equal to 0?
Yeah,
Okay. You set each one equal to 0?
you do.
Cube root 6.
See, this is where quadratics kind of shelter you a little bit. You can just do those in your head. Half the time, these you need to really actually calculate it out. Okay. So, all right, where does this go? Right? And so x is the cube root of negative 6.
Is it going to be plus or minus the cube root?
Good question. Do we need a plus or minus on a cube root? Why not?
Because cube, like, it's not the same thing as square root where negatives work, because if you take a negative, you do it 3 times, it's going to be a negative. If you do a positive,
Negatives can come outside of cube roots. Yeah, so cubics and cube roots are okay. All the odd roots are okay with negatives. So we have to worry about that. But if it's a square root or a quad root or a 6th root, any evens, that's when we add pluses or minuses. Okay. So there are your zeros. Right. So these are pretty straightforward, right? What you just have to do is recognize the pattern. See, that was 6, 3, and nothing, right? You can handle those?
Oh, yeah.
Yes, sir. Absolutely.
Because we can move on if you think you're good.
Can we do another example?
Wait.
You really want to?
Yeah.
Sort of. You're like, yeah, I'd rather have time to work on my homework, but
Precisely.
Fantastic. This is where I am instead of making stuff up. Okay, let's talk about factoring by grouping. I think that's going to work. The organization of this is where a lot of people trip up. So you have to make sure that you stay organized. Okay. Caleb, I trust you're with us on YouTube watching the stream. I think you're like,
I'm going to do it.
okay, factoring by grouping requires that you group, you see 4 terms, 1, 2, 3, 4, right? This is a 4-term method. Usually a cubic. Usually. The key here is that you group these and factor each of those with for a greatest common factor. So we're going to greatest common factor these two. with the goal of ending up with the same thing in both parentheses. Okay. So what can I factor out of here? 2. What else?
2x.
What else?
4
Squared.
2x squared.
Okay, what is remaining?
We got x plus 4.
Okay.
No, x squared plus
What about that one?
equal
4. What's remaining?
X plus 4.
Ooh, look at that.
No way.
Yeah, exactly.
Right. That right there is your goal on this, factoring by grouping. Okay.
No, it's,
You want these to be the same.
then it's 2y squared plus 4 times x plus 4x.
So, are you good with that? Sometimes you have to rearrange terms. It does get a little bit screwy at times.
How so?
Try to find one. Okay, so that's the first step. Now, this is a term, right? And that's a term. Is there a greatest common factor for both of those terms?
2. A plus.
X.
Factor that out. What's left?
2x plus 4. 2x squared plus 4. No way.
Right, so this is an exercise in greatest common factor group factoring. Okay. So you just do that. You do it twice. Try to make them the same with the first step, and then pull the same thing out the second step, and you got your factored polynomial. Okay. Zeros. If we asked you for the zeros, what are they?
-4. It's some crazy.
Yeah. So x is -4. I'm okay with you doing these ones in your head. Right? This one's actually pretty straightforward as well. So are there any real zeros here?
What?
Any real number zeros here with this one?
Oh.
But there are complex zeros, right?
Maybe we have to have one with funky rates.
Okay, so
Wait, why does that have to happen?
because there's a root of a negative, the complex numbers. Again, I'm not requiring you to plot those or anything of that nature. Just know that they exist. If you're going to be an engineer, they'll teach you how to use them. It is rather ironic that engineering has complex numbers in it, and they are useful, even though they are not real numbers. Yeah, it's weird. Okay, so that's factoring by grouping. Let's see if I can find a really kind of a screwy one. I have no idea why somebody did that, but okay. Let's try number 8. 224 AZ.
So it's square root
Okay, so this one's a little bit more involved, but I'm pretty sure you still don't need to rearrange. So when I'm looking at these, I'm trying to find common factors, right? So like in this one, you know, this multiplied by 4, right? And this was multiplied by 4. Those terms were multiples of 4 different. Multiples of x squared different. So when I'm looking at this one, what do I see? I see a z and a c, and a z and a c, right? Divide by 4, divide by 4. Right, so you got terms matching here, and then I'm dividing by 4 to get here to here and here to here. So I'm going to group just as it's written. Brandon, is that you too? Is it the math lesson? Very nice. I have calc students that take their notes off of the internet and just listen to the word. Yeah. Okay, so what are my factors, greatest common factors?
56.
I would, 56 is a factor,
224.
and 56 and A. Right, so 56A. What's left over?
C, 4, C,
ZC?
Right? Good. What is a factor of that? Negative 21. Why? And what's left? 4z plus c. That's the hardest part of these problems, is putting the right groups together and factoring.
How would you know if you had to rearrange the
I'll see if I can find one to show you. So now we factor this out, right?
How would you find zeros of that?
You wouldn't. How many variables are in that problem?
1, 2, 3,
4.
4.
How many are we used to seeing? 1. I'm pretty sure that you don't know how to do that. So there's not enough information here to figure that out. Right, so this is where you're done. It just says, it would just say factor, and you'd be done. Okay. Any questions on that one? Right. Let's see if I can find a mixer.
No.
You know, I don't.
You're winging it. Not from them, it's bad.
I think we're going to have to rearrange on 20.
Nice. Let's do it.
So 18 might be another rearranger. And I'm just taking a stab at this. So 112xy minus 16x. 120x squared. Okay, so I'm looking at this problem. I could factor an x out of here, right?
Yes.
And I'd be left with y minus something. Can I do the same thing with these variables?
No.
I cannot. So I know that my groups are not going to work as is. Okay. So how can I rearrange to make these work?
112 xy with the 14y and then the...
Okay, let's try it.
Why is it the y?
xy.
Okay, so rewriting, and there's not a whole lot of ways to rewrite this, so just try some.
Wait, where do you minus? Oh, I thought that was a plus.
Okay. I'll let you catch up. Okay, so I'm going to factor a y out here, right? So I'm left with x minus something. If I factor an x out of here, I'm left with x minus something, right? This is probably going to work. Let's give it a try. What's my greatest factor here? Greatest common factor? 14? Yeah. Well, that's 112 divided by 14.
8.
Right? It's 14y out of 14y.
And it's a negative.
You divide it.
Okay, what's my greatest common factor here? Probably 16x, huh? And I get 8x minus 1 again.
You're just coming up with a perfect deal.
I did not come up with these.
I was giving you
A lot of stuff I can wing it now.
You're not even money. Should have rolled here.
A lot of stuff I can wing it, but this is not something I want to try to wing because I might screw it up. All right. So what's my final factored form?
8x minus y, 14y plus 16.
Okay.
Is that all you gotta do this one?
We're done. Yep. Again, there's two variables. We're not going to worry about the zeros because we don't do three-dimensional graphing in high school math. I think I've shown you just about everything I can show you. The best thing for you to do is try them. Okay, there are two worksheets attached on Google Classroom. I'm asking you to do 1 through 9 odd. So 10 problems total there and 5 spiraling. Okay, it's about a normal day. I don't think I'd put any of the hard ones on these, to be honest with you. So, but I might be wrong, but I think you're in the clear there on like that last one I showed you. Yikes. So just give those a shot. I'm looking for you to have a basic understanding of these processes.
What do you want me to try?
I'm sorry, what did you say? Let's do tomorrow. He's going to lose. Any questions? I thought that's what it was. Stop playing with that. Yeah, do your math homework. Learn more. I'd like you to earn at least a 2 tomorrow when we grade your work.
That's kind of a high standard for him.
That's why I said at least.